Now there's a lot going on in chapter 1. Okay, a ton for you guys to remember. Chapters are different in this book. Some chapters don't quite have as much. Some might have even a little bit more. This is kind of a whole different concept. This isn't going to be about center shape spread outliers or anything like that. So this kind of threw this into chapter 1. It's something we're going to use in the very near future, but it doesn't really go with this stuff. So keep that in mind as we're going along. Here's what we're going to learn about today. Something called linear transformation. What if, so I've got these numbers, and what if I do the same thing to every one of them? Like, for example, let's say I add 30 to all of them. So instead of having these numbers, I have 35, 40, 40, and so on. Now what we want to study is, okay, so let's say we add a constant to every single one of those. How is that going to affect these summary statistics? So I want you to think about that right now. So let's say you add 30 to every single one of those numbers. I want you to do some predictions for me. How, if at all, do you think it'll affect the mean, the median, the standard deviation, the IQR, or the quartiles? Okay, you're going to add 30 to every number. Jason, what do you think about the mean? Think it's going to have any effect on the mean, and if so, what?
Yeah, for the mean, it is going to be a higher number.
Okay.
Because you're adding, because the numbers.
Because these are all higher numbers, right?
Yeah.
Okay. Do you have a prediction on exactly how much higher? Remember, we're going to say, what did I say? Did I add 30 or 50? What did I say? 30. We're going to add 30 to every single number.
How many numbers are there?
I don't know. Tell me. 15?
I'm going to guess it has to do something with the number you're adding and how many times. So
Okay.
maybe 30 divided by 15 to
Okay. Everyone, it's going to go up by 2. Okay, what do you got?
30. Or it's going to increase by 30.
So you think our new mean is going to be 53.5?
Yeah, because if you add 30 to all of them, it's going
Okay, good. That's our 2 predictions. Okay, what about the median? Same thing. I got 2 different answers over here. Which one do you pick?
increase by 30.
You think it's going to increase by 30 as well?
50.
Okay. All right. We'll check in a second. Just making predictions here. What about the spread? What about the standard deviation?
Stay the same.
Shh. What do you? So you think it's going to stay the same? Why?
Because all the numbers are going to be like the same spread apart. Because all the numbers are going to be the same distance apart.
Okay. So remember what standard deviation means. He's saying that the difference from the mean is not going to change. Is that what you're saying?
Yeah.
Okay. You going to change your answer?
Back?
Yeah. You have to toss it. I can throw it. IQR. Keep on that. What do you think about IQR?
Well, I think it's still going to stay the same.
Stay the same. Okay. And then these quartiles. We'll see what's happening. Let's just try that. Now, I don't want, what we're doing right now in the calculator, I don't want you to do this on your homework tonight. Your job is just going to be able to know without doing it. But I just want to show you what happens. And we practiced with this yesterday, so it's a good calculator exercise for us. So what I want to do is add 30 to each one of those. Now remember, I don't want you to do this on your homework tonight or anything like that. We're just trying to get an idea of what happens here. So follow along with me. So I've got all my numbers in L1. Okay. And what I want to do is add 30 to every single number. So remember how we do that to every single number. Go highlight the top. And then we'll do L1 plus 30. Hit enter. And you see how all of the numbers are now added 30 to it. Okay, go do a 1-bar stat on L2 and see how our predictions turned out. How about the mean? Did it go up exactly 30? Okay, the median, did it go up exactly 30? And then what happened to the spread? Nothing, right? It stayed the same spread out. Let me show you, let me draw a couple of box plots. Maybe this will help you see it. You don't have to do this, but turn on plot 2, L2, now the zoom stat. I don't have to set it up. Notice what happened here. Right? Didn't the graph just shift over 30, but did it stay the same spread out? Absolutely. Okay. So, let's come up with some general rules here. If I have a group of numbers, and I have a mean, a median, a standard deviation, and an IQR, and I add or subtract a constant. It's the same thing, right? If I subtract it the other way. What's my new mean going to be? Well, you just take that constant, you add or subtract the old mean, and you've got your new mean. Then we take the old mean, 23.5, add 30, I've got my new mean. Same thing for the median. Take that constant, add or subtract the old median, and you've got your new median. I've got my old median here of 20. I'm going to add 32 in the way I go. But here's where things got a little weird. Okay? Here, if I add a constant, did anything happen to my standard deviation? Nope. Or how about the IQR? All right. Let's add a level of complexity to it. Now let's multiply by a constant. So I want you to think of those original numbers now, and let's multiply by 4. So I'm going to take every number in that group. Not in calculator yet. Just hang on. I want you to do some predictions here for me. We're going to take every single one of these numbers and multiply it by 4. So this is going to become 20, that's going to become 40, and so on. That's our new data set. What I want you to try to predict is what's going to happen to these guys. For a second. All right, Jenna. What do you think about the mean? The old mean was 20. So you think the new mean is going to be, around close to 100. Okay. Multiply that by 4. Okay. How about median?
I think it'll also go up.
Times by 4.
Yeah.
So your guess is 80.
Yeah.
Okay. How about spread? How about the standard deviation?
I think the spread's the same because they all went up by the same.
Okay. By the same. Multiply by 4. And so IQR same as well. Marika? What do you think? What do you think about the mean? Multiply by 4. This is going to become 20. That's going to become 40. By, I know it's going to go up, but by how much? Do you agree? Do you think it's going to get 4 times bigger?
4 times bigger.
Okay. How about the median?
That's going to go up by 4 times.
Okay. How about standard deviation? You think it'll get bigger? So you're going away from Jenny. You think it's going to get bigger?
Yeah, because 5 times 4 would be 20, and then 75 times 4 would be 300.
That's really good. Okay, she got it. That's really, really good. Okay, let's take a look at that. No, I don't understand. I've done this for 10 years, and I think it's brilliant, but nobody ever understands what I'm doing. So maybe both box plots you'll get. This is a big number line. Okay, we got a big number line. And I got, think of it as a box plot. So I got my original data here. It's 5 to 75. Okay, so everybody with box plot, number line? Okay. So I'm going to multiply everything by 4. So you hit it right on the head. This guy, the 5, is going to go to the 20. Okay? But the 75 is going to go, what'd you say? 300. And you see how much more spread out it got? Okay? So you see how the spread's not going to stay the same? Okay? Like I said, just showing them this picture. I want you to... I thought that was brilliant. The whole thing, I thought I was going to get Teacher of the Year one year, and it didn't happen. Multiply them all by 4. All right, now I'm going to do the 2 box plots. I'll do a zoom stat, so it puts it on. And do you see how one of them, they moved over, right? It moved over, times by 4, they all got bigger. But you see how one of them got much wider as well. And in fact, they're going to get exactly 4 times wider. Okay, go and do that in your L2. Multiply them all by 4 and double check that the mean, the median, the standard deviation, and the IQR all got 4 times bigger. So our new mean around 90 something, new median at 80, new standard deviation at about whatever that is, 18 times 4, new IQR at 80. Okay? All right, so we can fill in our charts a little more. Our new mean is going to be whatever you multiply it. Multiply that by the old mean, you've got the new mean. Our new median, take whatever number you're multiplying it by, multiply it by the new median. You've got your old median, you've got your new median. Now standard deviation, it got wider. So you multiply that constant by the standard deviation, you've got VS, which probably you all think this class is, but that's what you got. And then finally you can multiply your constant by the IQR, and you've got your new IQ. Alright, now without doing it in our calculator, I want you to fill in this last row. Here's what we're going to do this time. We're going to multiply by 4 and then add 30. So you're going to take each one of those numbers, multiply it by 4. 5 times 4 is 20. Add 30, 50. This guy becomes 50. And so on. Can you fill in what you think is going to happen in this last row? What's my new mean going to be? What's my new median going to be? What's my new standard deviation going to be? And what's my new IQR going to be? They can multiply them all by 4, then add 30. Multiply by 4, then add 30. All right, Claudine, what do you got for the new mean? What do you think about the new mean? The old mean was 23.5. What do you think my new mean is going to be? What do I do to it?
I think the mean is going to multiply by 4, and then the 30 is going to be on the constant.
That's exactly right. She said multiply by 4 and add 30. She's exactly right. Okay, the new mean is going to be all that way over. So, to find the new mean, you add the constant, multiply, and multiply it by the old mean. Same thing is going to hold for the median. Add the constant, multiply it by the constant, and go. Now how about for standard deviation? Daniel? Who's Daniel?
Oh, I go by DJ, but
DJ.
it would just be the number you multiply by times the standard deviation.
So you're not adding the 30?
You're not adding.
Correct. Does everybody see why now? Here we go. Here we go. All right, so I got my original data, right? I'm going to multiply by the 4. Right? There's my spread. And now I add 30. Did the spread change at all? No. So it's only the multiplication that changes the spread. So you're exactly right. We still got BS here. And then there's your IQR. The same thing happens there. Okay. So what you're going to have to do is they'll give you the old information, and then they'll tell you to do some sort of linear transformation. They're going to want the new stuff. So you have to keep those rules in mind. Okay. All right, there's actually one other thing that's not on the board. I want you to take a look at it. What if you're comparing different data sets at the same time? You've already done this, remember? If I have different data sets I'm looking about, I draw one number line and we drew the multiple box plots on top of the one number line. You don't want to draw one number line, do a box plot, draw another number line, do a box plot, and have to compare them. You don't want that. You want them all on the same number line. Well, here's another couple of examples of different plots that we've learned where you did the same thing. Turn to page 57. That's way back in the day. It's a bar chart. Learned that a long time ago. Now, that's a bar chart comparing categorical data, but in each category there's different things that they're comparing. Well, put them on the same graph. Don't make one bar chart, then another bar chart, and have to look back and forth to compare them. Just compare them. Now, what you do need is a key there, right? You see the key that explains what the different colors mean. But you can just simply do that. Or another graph, turn the page. That's a stem plot comparing two different sets of numbers. Now, what the heck's going on here? Well, they just did their normal stem plot. They drew the stem, and then they drew the leaves off on one side. But now they want to compare a different set of data. Well, just do the same thing on the other side. Now you've got those two different sets of data using the same stem, and you can look at center, shape, spread, and outlier, and it's all there in front of you. Now obviously if you have 3 sets of data you can't do that, but if you have 3 sets of data you can just do 3 box plots under one number line. So if you're comparing multiple sets of data, please don't draw different scales, draw different axes, just draw them on the same line. Yeah.
So, let's say you're doing this problem and you're trying to figure out which way it's skewed. Would it be skewed right or left?
Okay, so which numbers are you looking at, male or female?
Male.
Okay, I would say that's definitely skewed right, because don't you have to draw the line a long way further to get to the larger numbers? So somehow, you try to get that number line on your going horizontal and see which way you're going to be going, but that's skewed right because I'm going to have to draw that line a lot further out to the bigger numbers. Okay, any other questions on this? Yeah.
So for the double stem plot, you'd have to do 2 keys for both sides.
Yes, because it's it's going to look a little different. Yeah, exactly. Okay. Anything else? Okay, that's good.